Okay, to solve question 39, like 38 and 35, it says to factor. If you take a look here, even though this is not a quadratic function, it can be written in quadratic form. And I've already done that. X cubed to the second plus 16, x cubed to the first plus 64, x cubed to the 0. 2, 1, 0. So this can be written in quadratic form. And because it can be written in quadratic form, we can use the quadratic formula to solve, or we could factor. If we use the quadratic formula, it wouldn't be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It would be x cubed is equal to that. Or we could factor, and we could factor this pretty easily. But because this is x cubed squared, instead of being x, this is going to be x cubed and x cubed. Multiplied together gives you 64, and added together gives you 16, would be 8 and 8. Even though we factored this, we haven't factored it completely. We want to factor this down further. It's the sum of cubes, so it's a binomial times a trinomial. This will be the exact same. Binomial times a trinomial. It's going to be plus, minus, plus, plus, minus, plus, x, 2x squared minus 2x plus 4x plus 2, x squared minus 2x plus 4. Now it is completely factored. Both of these factors, x plus 2 set equal to 0, give us an x value of negative 2 with a multiplicity of 2. Okay, and here we're going to have to plug this into the quadratic formula because it can't be factored. So we have x equals negative b, which is 2 plus or minus the square root of b squared, which is 4 minus 4ac, which would be 16. So in this case, for b squared minus 4ac, so in this case it should be negative 12. All over 2a, which is going to be 2. So x is equal to 2 plus or minus 2I radical 3 over 2. So x equals 1 plus or minus I radical 3. This is the value of x both here and here. So we would have this twice. So then we have 1 plus I radical 3 with the multiplicity of 2. And x equals 1 minus I radical 3, also ditto, with a multiplicity of 2. And that gives us our 6 roots. And I believe I did that math correctly there on the quadratic formula. So that should work. Now we only have 2 real zeros, actually 1 with a multiplicity of 2. So let's graph just to double check. X to the 6th plus 16 x cubed plus 64 equals y. When we graph this, there's our double root of negative 2. Let's zoom out. And there's what the rest of the function looks like. Okay, there we have what would appear to be some imaginary zeros. 6th degree polynomial function, and that appears to be correct, and that's how you solve question 39.